Ladies and gentlemen, this is the mass versus weight notes. This is to summarize our discussion of the downward force lab, and it's also to help you answer the questions and finish up this material before the end of our unit, which is coming fast. So to compare mass and weight, we're going to make a T-chart. We're going to put mass on the left column and weight on the right-hand column. By the way, everything I write, you write. And then when you come to class tomorrow, you will get a stamp for completion. So everything I write, you write, and get a stamp. Sorry about the mic here so far. But mass, going back to definitions, mass is the amount of stuff, which is a fancy word for matter, which is a measure of the atoms, the molecules, whatever, that makes it up. Weight, on the other hand, is the pull of gravity on a mass. Now, in physics land, it is important that we know the difference between mass and weight because, well, 200 years ago, we didn't really care about the difference between mass and weight because we only ever stayed on the surface of the Earth. But as soon as we started going off the surface of the Earth, then the difference between mass and weight became very important because if you go somewhere where you change your gravity, then you're going to change the weight of the object. So if you are on the International Space Station in orbit, the weight of the object isn't important, but the mass is. You go to the moon, the mass stays the same, but the weight is very different. Mass is a measure of inertia. Remember, inertia is laziness. The more inertia something has, the lazier it is. And mass, we use a triple beam balance. W slash is width, a triple beam balance. And weight is measured with a spring scale. Now, the spring scales are definitely a measure of gravity because in order to get a reading on them, you have to pull down, or gravity pulls down on the object. The more mass you put on here, then the more gravity is going to pull down on it. The unit for mass is the kilogram or gram. Weight, the unit is the Newton. There, you can see that. Now, the important bit here is how can we change them? So how can we change mass? How can we change weight? The only way we can change mass is by adding or removing stuff. Write the word pickles on the back of your paper for a second stamp today. That's the only way I can change the mass. To change the weight, I can change the mass, or I can change the gravity. I can go to the moon. I can go to Jupiter. I can go to Mars. Anywhere I go that is not the Earth, then I'm going to change my gravity. So that's a summary there of mass and weight, of what they are, kind of the definition. So now let's compare them. So the lab we're doing is about the relationship between mass and weight. So the relationship between mass and weight. On your graph for your lab, you put mass down here and you put weight on the side. Now, mass was our independent variable because what we were changing from trial to trial was the amount of beans in the bag. And in order to have weight, we have to have mass. So that makes mass our independent variable. And our mass went up to 0.5 kilograms, and our weight went up to 5 newtons. And you'll notice that there was a nice symmetry in our numbers. So if it was 0.5 kilograms, it was 5 newtons. If it was 0.2 kilograms, then it was 2 newtons. So we came to the relationship that mass times 10 equals the weight. The mass times 10 equals the weight, which means gravity pulls 10 newtons per kilogram. That's the relationship between mass and weight on Earth, is that gravity is pulling 10 kilograms. I'm sorry, back that up. Gravity pulls 10 newtons for every kilogram. And this relationship is the same whether or not we're talking about teeny tiny numbers like we did in lab, or whether or not we are talking about really big masses like the mass of you or someone else. By the way, the mass of a typical 8th grader is anywhere between 60 newtons and 90 newtons for mass. That's going to give you a weight range between about 600 newtons, remember the times 10, up to 900 newtons. Write ketchup on the back of your paper as well for a third stamp. Have a good day.